and I'm going to do the quick presentation on assignment 2, which is Apple quality. Here is the code that I implemented to classify, and in when I'm doing this preparation, the preparation for the presentation. In this assignment, I learned a lot. I learned about machine learning. I learned about underlying adaptive linear neuron and a model to classify the good apple from the bad apple. And also, I learned how to implement the how to use the code to classify something good from something bad, and it led me to learn more about machine learning and how the AI interact with end-to-end code and using the batch gradient descent. So I'm going to go through this exercise, and it's going to take a little bit longer than the minute required in the assignment. Please give me that chance to present my content fully. So, coming to the code, as you can see, I created my own repo here, and from the beginning here, I just put all the libraries and the libraries and the binaries that may help me to work together to be able to implement this. So, in the first place, I defined at the line implementation, and this implementation lead me to define the key parameters that will be using batch gradient descent to put all the learning rate together to work. So I jump in to define the few parameters to work, and the most important things is to how to range from one object to another object. So coming down to the data setup and exploration, which is the first assignment in the down report. So this is how I implement it. So I have to upload the data, the Apple quality CVS file, which is the data sheet, which is very huge. We have here, I put here like 4,000, which is 2,000 for the bad and 2,000 for good. So in this step, I defined 7 steps. 7 steps where we have the size, we have the weight, we have the sweetness, we have the crunchiness, we have the juiciness, and ripeness and the acidity. So those we are going to see them through this presentation. So let me go back to the code. So going to the code, this is the first step. The second step with the distribution feature, and I elaborate this to design the map, the diagram, the distribution feature that is going to present that distribution feature. We can see it from the this here. This is a distribution by Apple quality, and by the quality also, yes. So here, as I mentioned it, I have 7 steps. So I have size, weight, sweetness, crunchiness, juiciness, ripeness, and the acidity. So all this is defined here in the code here. So as you can see, uh, yeah, it's defined. I defined them through this distribution center, as you can see from here. That's what I show you on the screen shot. So from there, I'm going to jump on the coloration heap map. The coloration heap map is what? Is to define the key related between all the 7 steps, the 7 size or the steps that I defined to detect the bad apple from the good ones. So as we can see from here, and this is a part of the code which is giving me this image. So going back to the code, um, that's the coloration heap map, and then I have the preparing training and testing set. So this one also, I believe this is it. I defined it here, and as I defined it here, I'm going to in this area. We can standardize. We can do the standardization of the form, the size, the weight of the apple. So then I come down to now to build here the align model. The model will help us in terms of predicting. That this model is it help us to predict which one is going to be good, which one is going to be bad. So after that, I had to improve now that model by using the hyperparameter to tune the model to improve from when there's a given number or given size. So the model will be able to predict whether it's good or not. So that's what I defined here. As we can see from this page, this is one of the that steps. So as each point of exploration, you're still going to see the weight, size, ripeness, consciousness, acidity, juiciness, and the sweetness. So coming back to the code, let's go. So I define across the model, and then I'm going to get the output, final output. Now I'm going to execute my code to show the final output. So making the prediction. After the prediction, now we can get the final output to see the what is correct, what is not correct, what is bad, what is good. So coming down all the way to model verification, we have to verify the model that I defined to have all these screenshot down. So after that, now we come to the importance of weight, magnitude, and after that we have to come to the final apple quality and identification result. And in this result, I'm going to put all these results to my technical reports and explain it, put a comment on it, and so you can see. As at the end of this, so as you can see in the at the end of this result here, I put down good apple is going to be this, and the bad apple is going to be this. So this is how I built the code to give me a successful output, and I'm going to give add a few screenshots of this to my technical report that I'm going to submit as assignment, and also attach the code I'm explaining. I'm going to attach this code to the assignment, but I may not be able to. Probably I don't know if I'll be able to attach all the screenshot, but I will try to see if I can give all the screenshot with the comments to this assignment. So let me jump in the terminal to execute the code so you can see the successful output of it. Now I'm in my terminal. So now I just cd into the apple, and then I'm going to read the content. So you can see this is the content of what I have in the code here. But I'm going to execute this content to show the successful output, and then I'll be attaching the output result to it. So since this is my main file, so I'm going to execute this main file to see the output. So let's see, since I'm using Python, so I'm going to use Python 3, and I'm going to add the line. Let's see if it's going to give me. Okay, so I'm executing the output now. So the code is executing, and I'm waiting for the the output, the results. So it's taking a few minutes to execute. So I'm going to pause the video. Once the execution complete, I will resume the video to explain the execution steps. I will explain the outputs. Yep, as I execute the command here, so my command executed successfully, and as you can see from the in each square and the workflow overflow, my code executed successfully, and it giving me the data setup exploration. As you can see one here, so this is the data set, the output. You can see quality of the apple. We have a good, bad, good, bad, good, bad, and bad, bad. So and the column, you can, as you can see here, as a ID for each one, we have a size, weight, sweetness, consciousness. As I define it, everything is executed successfully here. As you can see, if you take the weight, the size, we have a number of it. We take the weight, we have a number of it. We take the juiciness, we have it. Ripeness, acidity, we have it. This is the outputs, and these all the feature. These are already explained in my first steps. So as you can see, after standardization, you can see the output. Here is the training that with the means and the square and the error and square of errors. So building the underlying models. So all this is giving me very successful output, and the test in the test case, all the results are here, as you can see. So I'm going to attach these results to my assignment. As you can see in the final report or model or performance overall accuracy, it giving me taking like 85% of my code to choose the bad, or to classify the bad or the good. So as you can see, and I just pick up a few, like a four, and in the four it's a 50%. So you have two, you have a one bad, one as a good, two as a bad, three as good, and four as bad. So I make it here as a 50-50. So this is the end of my presentation. I'll be adding this link to my report, my technical report, which I have here, and this technical report, I'm going to put it in the Word format with all the contents that I'm going to add to it, and submit as a one single assignment. But I will be attaching the code also. Thank you for watching, and yeah, thank you for watching. Thank you, and thank you again.